I have another simulation for you to mess around with. Your assignment gives you some kind of guidance on what to think about as you play around with this simulation. But at this point, I really do want to move into this mode of when you use a simulation like this, it is to find things out for yourself, to play with it, to kind of try to break it, to see, can I push this to an extreme? What happens if I do this? And then whenever you're doing that, to kind of think, okay, what do I expect to happen when I do this? Generally, you have some idea. And that's the really cool thing about playing around with something like this. Sometimes you get confirmed in what you thought would happen, and sometimes you get surprised. And either way, it's pretty cool. So I just wanted to do this video just to show you how this simulation operates and the things that it can do. And mostly I want you to play around with it. And if you just feel like I don't really know where to begin, you can go through the assignment and figure out, okay, what does Sarah suggest that I do? But the most important thing is that you play around with it. So you've got this chamber here. It's kind of box divided into two. You'll notice that each side of the chamber is the same size. So when we refer to size in science, we're often referring to volume. In other words, how much space something takes up. So you've got the same amount of space on the left side over here as the right side, and you've got a barrier in the middle. So we can kind of think of that as a membrane. What you've seen from the previous simulation is that membranes are a form of barrier. When you have a cell membrane, it's kind of designed to keep the inside of the cell in and the outside world out. And then there are certain gates and passageways and certain things that can get across because the cell needs to get supplies in and needs to get the waste out. So there has to be some kind of passageway, but effectively, it's a barrier. So you've got this box divided in two by this membrane in the middle. And at the beginning of the simulation, it's a solid line. So it's a membrane that just excludes everything. There are no holes in it. There are no channels, nothing like that. You have this optional drop down here where you can see some data, some actual information about what's going on. And then you've got this control panel over here on the right. So the things that you can control over here, similar to the last simulation, you control how many particles. So you can think of these as atoms or molecules, but we're going to use just the general term particles. And you can add however many you want. So 20, 30, 40, 50, you can keep going. You can add like a ridiculous amount of particles. That's kind of entertaining. You can leave the other side empty. You can put particles in the other side, whatever you want to do. So you can put in a few red ones if you want to do that. So you'll see your data readout changes as you change things over here in the control panel. It's giving you a count. So you've got 200 blue particles on the left side, and you've got 0 blue particles on the right side. Conversely, you have 10 red particles on the right side and 0 red particles on the left side. And then over here, the last piece of data that you're getting here is T average. So that's average temperature. If you've never seen K as an indicator of temperature, that's fine. It's a very science specific way of measuring temperature. We don't say it. So this capital K stands for Kelvin. We don't actually say Kelvin degrees. So, like we would say degrees Fahrenheit or degrees Celsius. We don't say degrees for Kelvin, we just say plain Kelvin. So, the temperature on the left side is 300 Kelvin. The temperature on the right side is also 300 Kelvin. So, that's the readout for what's going on inside of these two chambers. And you can mess around with this, you can change it, you can add more particles, you can subtract particles, you can do whatever you want. Next thing you can control is the mass of the particles. So this is how much stuff they're made out of. In a way, you can think of it as how heavy are they, kind of how much do they weigh. So you can crank things up and you can make the blue ones quite heavy. So 32 AMU, you may not have seen that unit before either. AMU is a unit of mass. So like if you were weighing something big, you might use kilograms or pounds or something like that. With something as tiny as atoms and molecules, we usually use the unit AMU. So we're essentially weighing these particles. I'm using that term not quite precisely in a scientific sense, but it generally helps me to understand that's what I mean. So the mass of the blue ones, I've now got at 32. You could decide to make the red ones very light. So I'm going to make the red ones kind of as light as I can make them. They're only 4 AMU. So now you'll notice that the particles look to be the same size, right? So the volume of the particle, how much space they take up, is the same. So the blue ones look like they're the same size sphere as the red ones, but our mass over here is saying they don't weigh the same. So it's kind of like if you took a piece of styrofoam in one hand and a brick, the same shape, in the other hand, and you know that even though they look the same size, they take up the same amount of space, the brick feels a lot heavier in your hand than the styrofoam. That's the phenomenon we're talking about here. The particles will stay the same volume, they'll stay the same shape and size, but one kind will be much heavier if you mess around with this mass thing over here. So you can play with that. You can see what effect it has. You can already see maybe some differences going on. You'll see maybe differences in behavior as you play around with the mass of the particles that you should think about. You can actually change how big they are. So radius means like how much space they take up. Radius is like how big are they across. This is kind of entertaining. I like that. So you can play with that. You not only can change the mass of the particles, you can change just the mass and not change their shape. You can use the radius adjuster to change their shape. So you can make the red ones like really tiny. So you can play around with just the mass or just the radius, or you can mess with both. I encourage you to play around with this as far as your curiosity wants to take you. And the best thing you can do here is to ask questions. So if you notice something, jot down what you notice. If you have a question about that thing that you noticed, jot down the question. That's really what I want to do. I just want to use this kind of as a question collector for the first phase of this. And then we will get to more specifics. But this is just first phase. Anything you notice, anything you wonder about, anything you messed with and were like, huh, when I did this, I saw that this happened. So same deal here. You can play with the temperature. So you can make it colder. So let's say we take the red guys and we drop their temperature down to 50 Kelvin. We can crank up the temperature. So we can make the temperature of the guys on the left side 500 Kelvin. And then finally, what you can do is once you've kind of played around with these parameters, you can poke holes in the membrane, right? So you can give these things a way to get through, right? So you're going to see how they behave. So you can mess around with them in separate chambers, and then you can set them free, and you can open up holes in the membrane and let them do whatever they're going to do and observe what you see. So I can't overestimate how critically of interest your observations are. I'm not really going to ask you factual questions at this point. I just want to see what you notice by playing around with this. Mess with it as many ways as you can. Try to pull as many ideas from it as you can. You'll see down here you've got additional things you can have it show you. They may not make a lot of sense to you, but that's kind of a cool thing with a simulation is you can just kind of play around with it and be like, what is this telling me? So I can reset my divider and this center of mass thing. I've got these little bars down here. I don't know what they're showing me. When I remove the divider, okay, the bars change. Not sure what that means. So that's something you might wonder about, okay? So you can take that away. You can do particle flow rate. So I'm not going to play around with all of this stuff, but you can see, like if you decide to have it show you any of these things, you can have a scale on there to measure things. You can have a stopwatch, see how long something takes. So if you want to kind of test one thing and then say, okay, I wonder if it happens faster if I do this. I wonder if it goes slower if I do this. Well, you can run a little experiment, so you can say, all right, I'm going to start my stopwatch. I'm going to remove the divider and I'm going to see how long it takes for whatever to happen. So that's what I want you to do for right now. You've also got a little speed controller down here so you can watch things in slow motion if you want to. Sometimes it's hard to notice what's going on when it's going full speed. You can pause things. And then if you want to just, resetting the divider will take you back to whatever, you had for a setup. If you just want a completely fresh start, hit this little orange button and it will erase everything and it will bring all these parameters back to the starting condition. So you can run this as many times as you want. You can clear it, rerun it, new scenarios. Just do what good science dictates, which is that you should record in some way. So you can, like write this down, jot down some notes to yourself. What do you notice? So what do you notice? What do you wonder? What predictions did you have? Did anything surprise you? No, did you kind of have an expectation that didn't go the way you thought it did? And then probably above all, what questions did it generate for you? So I'm going to leave this assignment pretty open-ended for right now. We're going to have some more specific things that we need to pin down about how things move from place to place in the body, in a cell, in a living thing. But right now, I'm mostly interested in just leaving it wide open for you to tell me what you see and what you wonder about. So tackle that, play around with this thing as much as you want. And then in the assignment, I ask you to kind of share what you got out of it. So do that, and that's how you'll get credit for this assignment.